Welcome to the presentation. Today I'm going to talk a little bit about sentence embeddings, to be specific, LASER, otherwise known as language agnostic sentence representation, which was introduced by Facebook AI Research. Let's give a brief insight into my thesis first. In this research, we're tackling the problem of building a state-of-the-art data-driven neural machine translation system for Bengali English language pair. Our thesis objectives could be narrowed down as follows. First, creating a comprehensive parallel training corpus. A parallel training corpus is a collection of text pairs where each text pair is the translation of each other in two different languages. Neural translation models require a large amount of parallel sentence pairs, generally in the order of millions, to have any sort of decent performance. Due to Bengali English being a low resource pair, existing parallel data is really low, which are again mostly erroneous. So first, we need an automatic way to generate a significant number of high-quality parallel data from comparable corpora. This is where Laser comes in. Second, on top of the existing benchmarking datasets, we need to create a quality benchmarking dataset from varied genres to reliably compare results across systems. And finally, from the accumulated data, using the accumulated data, we need to create machine translation models for both Bengali to English and English to Bengali. Now let's see what are sentence embeddings. The idea is, given a sentence, we want to map that sentence to a vector space of fixed dimensions such that semantically similar sentences remain closer to each other in the vector space. We can see that in the figure, each of the four sentences has a three-dimensional vector representation, where the vectors for I love eating and I enjoy food a lot, which are semantically pretty much the same sentence, are close to each other, but are far away from semantically different sentences such as the dog is brown or I want to call you. Note that the embedding space here is monolingual, which means that the sentences here are all in English. Laser's idea is to introduce a shared multilingual embedding space. In this figure, the new sentences are German translations of the previous sentences. Notice that semantically similar sentences in both the languages are now close to each other in the embedding space. The actual laser model was trained on parallel data from 93 languages. Laser's vector representations of sentences are generic with respect to both the input language and the NLP task. This representation could be seen as a universal language in a semantic vector space. Let's see an actual illustration. Here we see groups of same sentence in different languages. Laser outputs a 1024 dimensional vector for each of these sentences. If we apply two-dimensional PCA on these vectors, we see that the vectors for each group are clustered together. This is the architecture of Laser. Without going into much detail, we only use the encoder to generate the sentence embeddings. The encoder is a stacked BiLSTM with 5 layers, each being 512 dimensional. Uh, the embeddings are generated by max pooling the last hidden states of the BiLSTM. Now we have a comparable corpora with some Bengali sentences on one side and some English sentences on the other. The straightforward way to collect the parallel sentence pairs would be to calculate the distances between all sentence pairs and select the closest one. The distance is actually normalized by considering the margin between the closest sentence and other nearest neighbors. Although this works just fine for high resource languages, for Bengali English, most of the obtained sentence pairs were erroneous. This could be attributed to the low amount of parallel data used in training Laser and high variability of the input distribution. To remedy this, we first align data using different distance-based statistical methods that leverage, for example, dictionaries, translations from a neural model, etc. We use Laser now on these aligned data to filter out incorrect alignments. We experimentally found this approach to produce much more accurate and larger yields in terms of obtained sentence pairs. Uh, this is pretty much it. Thank you very much.